Hello. So today's been a pretty rainy day and my head kind of hurts, but I managed to build the contraption or stand that can hold my phone so you can see my paper when I'm talking. And I used my cooking board to do that. I'll show you in a second. Which is why I'm filming this video right now, because I want to be able to use my cooking board tomorrow so that I can take the contraption apart for a moment. Anyway, here it is. Ta-da! And yes, I have my tea as well. So I think we have the usual by now. No high dopamine content. I have my tea. Grab your tea or drink of choice. And yeah, I will tell you what I explored a week ago for math. And let's see if it works, because I'm not really sure. But yeah, I'm gonna turn my phone. Hopefully you'll see the paper. Let me know how that works. Okay, here's the paper. I know you can see my shadow, but I think you can see the words. Anyway, pretend that I'm trying to explain, I don't know, pretend that I'm giving you a presentation or like a practice presentation, and so you get to tell me anything that's not clear. So I'm going to try to explain to you what I did and how I got there, and then at the point where my explanation starts to become confusing for you, you let me know. And maybe that just means that I don't understand what I did well enough yet, and I'll think about it more next time. So my exploration for the week started with coloring in numbers. It was inspired by a video that I watched on YouTube, which was by Vihart or Vihart. I still don't know how to say her YouTube name, so I have to check that out. But I'll put the link in the description. And so at first I was kind of just doing multiplication tables, and I put an X because this didn't get me anywhere and I wasn't interested in it. So I started following the method of I start with the 1 in the center, and then I kind of write the other numbers, like the countable numbers, going in a spiral. So I have 1, go down 2, 3, 4, 5, 6, 7, 8, 9, and then you keep going in this sort of spiral. And so here I started coloring all the different numbers. I think the even ones red, and I think the orange ones are multiples of 5. I think anything circled in a black circle is a multiple of 3, and then everything blue, was that supposed to be a prime number? It might have been. No, it can't be a prime number. I think I was trying to figure out what the pattern was between these. Yeah, anyway, sometimes you have to start somewhere, is my point. When you don't have a question, you just need to be inspired to try something. So I wrote out the same these same numbers in like a sort of 12 column list, which is different from this because here this was the multiplication table, so I was skipping numbers, but in both of these two charts or tables or pictures or I don't know, lists, I was writing specifically the countable numbers. And so here I noticed that whenever I wanted to make the 2, like multiples of 2, here I circled them in red. They were completely like in line here, and over here they were more scattered like a grid, which was like, okay, right? It's like, whatever, what are you doing here? I was like, I don't know what I'm doing here. But then I noticed something, that in the spirals, with every single layer that I added, it's like we were adding a new square. And this first square, we just had one square in the middle. Then we had the second layer, which had 3 numbers on each side of the square, which was like this. Then we had another layer which had 5 numbers, and I started asking questions about this. I was like, okay, so like for this first one, I noticed that each side has 3 numbers, right? But the square itself has a total of 8 numbers. So if we take out this center, if we're just talking about that layer, then I was like, okay, let's think about the next layer. This has 5 numbers on each side, but the square has a total of 16 numbers, which we can count them, right? Which is just like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then I was thinking, okay, I found some sort of pattern. How do I write a formula for this? So then my first question was, okay, well, do I skip the 1 square? Because I don't really know where that goes into the formula. So I was like, okay, that's a good question, but I'll come back to it later. So I said, let's define a variable n, because that's what we do in math. We define some variables. And then I thought, okay, well, this formula seems to work, where n is the number of numbers per side of the square. So like here it's 3, here it's 5, here it's 7. Then we subtract 2, because that's the number of corners on every single side, right? Obviously, what we're trying to do is not count the corners twice. Every single side experiences both corners, but we're not counting them twice. So I was like, okay, let's subtract all the corners from the equation at first. Then I was like, okay, multiply by 4. So we are getting the total number of numbers minus the corners, that's essentially this part of the equation, plus, and then we just add the corners back in. I was like, okay, that makes sense to me. So I realized though that if we start with a 1 in the middle, then the only number that we can have, like the only number of numbers, I guess, per layer that we can make is 3, 5, 7, 9, and I was like, okay, is this like a type of series? This was reminding me a little bit of when I was learning series, and I think it was Calculus 2, possibly in college. And I was like, okay, well, that's a pattern that I noticed, but I don't know what to do with it, so let's keep going. So I wrote a formula, so then I decided to test the formula. So when n equals 3, so that's this first layer right here, how many numbers do I get in that layer? I just decided to like label this number of numbers AT, because I didn't really want to keep repeating number of numbers, because that's like a weird thing to say. Maybe it's not weird, but I feel like, I don't know. Anyway, we get to choose, right? I get to choose. So 3 minus 2, right? That's 1 times 4 is 4 plus 4 is 8. Cool, that works, that's correct. Then I was like, okay, let me try it for n equals 5, n equals 7, and n equals 9. Each time that I tried the formula, it did work, because I think my logic was pretty solid to just first find the number of numbers minus the corners, and then just add the corners back in. My logic was pretty solid. And the thing I'm doing in this formula, the question that I'm answering specifically, is how many numbers are there in any given layer of this square? And the information that you have to give me is how many numbers there are on one side, right? So that's specifically what this formula is for. Given the number of numbers on one side, I will tell you how many numbers there are in that one layer of this bigger graph. And then I noticed, right, because we can move around variables and formulas, so I was like, okay, well, I made this. Can I make it simpler? And here is the simpler formula where I was like, wait a minute, there's a 4, right? I can use the regular, I think, distributive property. So 4n minus 4 times 2 is 8. That's what I have right over here, plus 4. And I'm like, wait, these two are just numbers, right? Like I could just put them together. We get 4n minus 4, and we can take that 4 out again. So the same exact formula, but in a different format, which looks a lot simpler. And I was like, okay, well, let me make sure I did that right as well. It's not like too many steps, but just to check. So I checked on n3, n equals 5, n equals 7, n equals 9. I was like, cool. Okay. So I also noticed that here, the number of numbers, right, in each square of the spiral, it's literally the 4 times table, but we're skipping all the odd numbers, so we're only doing the even numbers. And then I was like, okay, so what happens with the number 1 here? Like, 1 doesn't count because it's not an even number? And I was like, but is it? No, like 1 is an odd number, because the definition of an even number, which I don't know, I don't remember the formal one, but it has to do with, like, you know, the number 2. Something that's even must be able to be divisible by 2. And 1 is not that. 1 is not such. So I realized that something was kind of right, but not right with my formula, right? Because we were missing the 1, because if I put the 1 in here, right, suddenly we get 1 minus 1 equals 0, t equals 0, and that's not true because we have a square here. So that is not right. And then I was wondering, what did I write over here? I said, it doesn't matter what numbers we write in the spiral, in the squares. The equation that I'm telling you just tells you the number of numbers. What's actually written in it doesn't matter. And we could even omit all of the numbers inside of the spiral and just use colors per layer or something. Given that we like stick to the same number of squares, like whatever is in here, anyway, right, so the numbers become less important, and it's the number of numbers that become important. So then I was like, but wait, what if I wanted the total number of squares that we had given the total number of layers? So now the information I'm asking for you to give me is no longer how many numbers a given side has, but what layer we are in. So now I have to translate, okay, we're in layer 1, there's a 1. We're in layer 2, there's 3 numbers per side. We're in layer 3, there's 5 numbers per side. And I was thinking about that. I was like, okay, well, what does that look like? Well, if we were counting recursively, so if we weren't just trying, well, let me get to that in a second. If we were counting recursively, 1 square, we have 1 total. 2 squares, that same formula that I had before, right, plus 1, which is from the 1 square, so we get a 9. 3 squares is I would have that same formula that I had before, but I would do it twice. So I would do it once for when the number of sides was 5, once for when the number of sides was 3, and then I'd add that 1. So then I was like, okay, well, how do I know what number of numbers there are per side when you tell me what layer I'm in, which is kind of what I just said before, but this is the table of me figuring it out, right? Like layer 1, 1. 2, layer 2, 3 numbers. Layer 3, 5 numbers. And so here, For everyone who knows how to write summation notation, you will notice that I did it completely wrong because I did not remember how to write summation notation, but I realized that by doing something recursively, I was essentially bringing myself back to the question of summations and series. And I was like, hey, this is a series, isn't it? And I was trying to figure out what would work, right? Like the +1, I realized would actually have to go outside of the summation. And that makes the entire formula work. Because then, once I figured out what the summation looks like, which I will explain to you in a moment, then we just add that one outside of it. And so the whole summation, which is essentially a summation of this formula, it will give you 0 the first time, like when you put 1. However, this one outside now accounts for that one in the center. And so, since I knew I didn't remember how to use summation notation, I Googled it, right? Because that's what we do when we realize we have come to some place where we need more information. And so, yeah, I just did like a quick review of like, okay, this is what the summation sign looks like. Here's where like the formula goes. We have a starting point, which is the index, and we have a stopping point, which is the upper limit, which we could start at 1 and we could go to however far we want. And so what happened here? So essentially I used this I number instead of where I had n before. And what am I talking about? No, I'm wrong. Okay. So I was letting I actually be the number of layers. So here I was in like, okay, so here we have 2 squares. Here, so this is where I would need to switch this. I would need to put I equals 1, and we end at 2. Yeah, and here's where I realized I don't need the n anymore, because, let me see. Okay, my bad for the sort of odd explanation in this particular moment, but I remember what I did. So over here, ni, right? This is the formula that gives me what number of numbers there are per side given the layer. So if I had 1, I would do 1, what did I say? 3. So let's see. So 2 minus 1, right, is 1, plus 2 is 3. That works. 3 minus 1 is what? Oh, 3 minus 1 plus... This doesn't work. Why did I say, what is that? I don't remember what that is. I don't remember what I was trying to do there. But let's see if we can keep going and if I can figure out what I was doing. Ni minus 1. This is like the part in the lecture, right, when a professor in class is like, wait a minute, I know I did this, right, and I figured it out before, but that was like a moment ago and it wasn't this morning, and so I don't remember it right now. But so I minus 1. 2 minus 1 is just 1, plus 2 is 3. 3 minus 1 is 2, plus 2 is 5. Like, that doesn't work, right? Like, 4. So why was I adding? I think I might have just realized that I did something wrong, actually. So let me just point out that number 1, I was trying to write like a summation, a recursive summation, and in reality, this is all like kind of unnecessary, because if I just want the total number of numbers, it's just going to be like 7 times 7, right? If I want everything, if I don't want like a given layer, if I don't want the numbers in a given layer, if I want all of them, it's just going to be one side times the other side. It's just going to be the regular like multiplication. However, the interesting thing about the summation is that then I actually can count using a different lower limit and a different upper limit. So I can like start at layer 3 if I want and end at layer 10, or I can, start at level 1, end at level 5, start at level 3, end at level, 6. The point is, that's what makes the summation somewhat useful in that sense. And so maybe I'm going to go try and figure this out again, because clearly I might have done something wrong. But that's okay, because that's kind of how we figure math out. So it's a good thing that I'm trying to explain it to you, because if I just left it, I probably wouldn't have realized that I might have done something wrong. But the thing is, which I'm very excited about, is that I did make up my own question, and I was able to explore it. And it's a question that I could find an answer to, but didn't have an answer to right away. So I just want to clarify that the thing I'm most interested in isn't learning a specific type of math, even though I do like some more than others, but it's actually in learning how to ask the right questions and how to ask good questions, which I think are the ones that aren't too hard or too easy. Too easy is you know the answer right away. There's no exploration, there's nothing to solve. Too hard is you have no idea where to start, you don't have any tools. And so from what I made, I was able to explore something. And then that actually led to another question, which is like, how do you calculate what number is in each corner position if we do go up using the counting numbers? So that's sort of a next question that I can explore, given that I now am probably needing to go back and fix whatever this is. But yeah, so thanks for tuning in. Once again, none of this is going to be exactly, I don't really know what this is. I guess we'll keep figuring it out as we go along, but it's not me teaching you math, it's not you teaching me math, like, it's just trying to learn how to ask good questions and get better tools and learn how to play around with the numbers and patterns. So, yeah, thank you for tuning in, and have a good rest of your day or night or whatever. Yeah, I don't know.